Today we'll discuss ISI's B-Stat B-Math 2024 UGA paper, and actually I have solved this paper yesterday, but then somehow audio did not record, and I've already posted the screenshot of the solution in the community post. So now what I'll do is, rather than solving them again, I'll just go through all the solutions and explain the important parts. Now this question number 1, it's a very simple one. All we are given is a GP. For this GP, first term is 1, common ratio is 2 to the power 1 by 5, number of terms is 5. We can write sum of a GP. Using this, we'll get x. Now 2 to the power 1 by 5 is 1 plus 1 by x, or 1 plus 1 by x to the power 5 equals 2. Now they're asking for 1 plus 1 by x to the power 30. So we'll take 6th power. So if we take 6th power both sides, right hand side will be 2 to the power 6. That's your 64. And that'll be your option D. Now question number 2 is a very simple probability question. It says out of these 2024 numbers, we have to select a number and we need to find the probability that j is divisible by 9 and 15. Now when a number is divisible by both 9 and 15, it has to be divisible by LCM of 9 and 15. Now LCM of 9 and 15 is 45. So we need to choose numbers from 1 to 2024 which are divisible by 45. So if we divide 2024 with 45, we'll get this result as 44.9. So in this set, there are 44 numbers which are divisible by both 9 and 15. So this required probability is 44 divided by 2024, which is 1 by 46. And that's your option B. Now in question number 3, it says let Sn be set of all n-digit numbers whose digits are all 1 or 2 and there are no two consecutive 2s. Then the number of elements in S10 is. And that's a very standard question in recurrence relation. And we have solved a number of questions like no consecutive heads. So if we look at this Sn will have n digits. Now this last digit, it could be either 1 or 2. So there are only two cases. So last digit can be either 1 or 2. If it is 1, then there is no restriction. So the problem reduces to arrangements of 1 and 2 in the remaining n-1 places, which is Sn-1. But if the last digit is 2, we know that 2 cannot appear consecutively. So the number before 2 has to be 1. So these two places, they are fixed. Now we have to arrange 1s and 2s in the remaining n-2 places, and it can be done in Sn-2 ways. So basically this Sn, it is Sn-1 plus Sn-2. So it's a recurrence relation. And in order to find the value of S10, first we'll find S1 and S2. S1 is when we have only one element. So there'll be two such numbers, either will be 1 or 2. And for S2, it'll be 1, 1, 1, 2, 2, 1, but not 2, 2. So S3 is 3. So this is your S1 and that's your S2. Now S1 plus S2 is S3, which is 5. 5 plus 3, 8. 5 plus 8, 13. 13 plus 8, 21, 21 plus 13, 34, 34 plus 21, 55, 34 plus 55, 89, and 89 and 55 is 144, which is basically your S10, and that's your option C. Now this question number 4 is a simple binomial probability question. It says there are 30 true and false type questions. Out of this, a student knows the answer to 20 questions. We need to find the probability that the student gets exactly 20 answers correct. Now here the basic assumption is if a student knows the answer, he is going to mark the answer correctly. So for these 20 questions, the probability of getting the question right is simply 1. So the problem reduces to, we have 10 problems which are of the type true and false. So probability of success is 1 by 2 and probability of failure is also 1 by 2. And out of these 10 questions, a student has to get exactly 4 questions right. So we need to find probability of x equal to 4. Now this is nothing but 10c4. B to the power 4 and q to the power 6. Now we simplify this. It simplifies to 105 upon 2 to the power 9, and that's your option A. Now in question number 5, it says there is a triangle T in which sides are in GP and it's a right angle triangle, and it is asking for maximum number of integral sides in such triangles. Now let the sides be A, AR and AR square. Since it is a right angle triangle, it's going to follow Pythagoras theorem. So we can write a square plus ar square equals ar square whole square. So it will be a quadratic in r square, which if we want to solve, we'll get r square as 1 plus under root 5 by 2. We have discarded minus sign, and if we look at r will be under root of 1 plus root 5 by 2. Now as we can see in this question, both r and r square, they are irrational. Now we need to find how many sides of this triangle can be integer. Now we'll take this first case when a is an integer. So if a is an integer and we multiply an integer with r and r square, both of them ar and ar square, they'll be irrational. So there'll be only one integer side in this case. Now we look at the second case when suppose ar is an integer, and if ar is an integer, suppose k, then a is k by r and ar square is k into r. Now k is an integer, so k upon r and k into r, both of them they'll be irrational. So here also we can have only one integral side. And this third case is when ar square is integer. Now in this third case, suppose it is k. Now a is k upon r square and ar is k upon r. Now k is integer, both r and r square, they are irrational. So again these two sides, they'll be irrational. So in any case, maximum number of sides that can have integer length is 1, and that's your option B. Now in question number 6, we are given that sum of all xi's is equal to 1. So there are n numbers whose sum is 1, and we need to find maximum possible value of under root of xi. I varies from 1 to n, and x1, x2, xn are non-negative real numbers. Now in this question, what we'll do is we'll use Cauchy-Schwarz inequality, and we know that vector a dot b, it is less than or equal to mod of a into mod of b. Now we generally write this inequality as a1 b1 plus a2 b2 plus an bn whole square will be less than or equal to a1 square a2 square an square and b1 square b2 square plus bn square. So in this case, so we can write 1 into under root x1 plus 1 into under root x2 plus 1 into under root xn whole square will be less than equal to a1 square. So root x1 square is x1, so it will be x1 plus x2 plus xn into b1 plus b2 plus bn. So there will be 1 plus 1 plus 1 n times. Now this sum, it is 1, and this value, it is n. So under root of x1 plus x2 plus xn whole square, it is less than equal to n. So the maximum possible value of under root x is root n, and we know that we get this equality sign when a1 upon b1 equals a2 upon b2 equals an upon bn. So in this case, we will get this maximum value when all x1, x2, xn, they are equal, and they will be equal to 1 by n. So this sum will be simply 1 upon under root n, n times, and there will be root n. And that's your option B. Now in question number 7, we are asked to find the interval where this function is decreasing. Now there are two things about this function that we must know. One is it's a logarithmic function, so it will have its own domain, and the condition of domain will be x square minus 2x minus 3 should be greater than 0, and if we want to solve it, we'll get either x is greater than 3 or x is less than minus 1. And the second thing is this log is not on the natural base, it is in the base 1 by 2. So what we can do is we know log b base a is log b upon log a. So we'll express this as ln x square minus 2x minus 3 upon ln 0.5 or minus log 2. Now this log 0.5 or minus log 2 is nothing but a negative value. So we'll take this minus sign, and then if we differentiate this log function, we'll get this as 1 upon x square minus 2x minus 3 into 2x minus 3. Now we look at the critical points. The critical points are minus 1, 1 and 3. And we have this minus sign, so rightmost is minus, so leave minus, plus, minus and plus. We need where this function is decreasing, minus sign. So minus sign occurs when x is greater than 3 or between minus 1 and 1. But minus 1 and 1, it doesn't lie in the domain of this function. So the only option correct here is x should be greater than 3, and that's your option B. Now in question number 8, we are given two circles and we need to find angles subtended by their common chord at origin. Now first we need to find its common chord. Now common chord is basically nothing but radical axis, which is given by S1 minus S2 equals 0. So we'll subtract one equation from other, and if we do that, we'll get equation of this common chord as x plus y equals 6. Now there are two ways to do it. If we look at this second circle, its center is 3, 3, lie on this line. So this is x plus y equals 6 and center is 3, 3, and it also passes through origin. So this is diameter, and we know that angle subtended in a semicircle is 90 degrees. So answer to this question is pi by 2. Another way to solve this question is, we have this circle x square plus y square equal to 1, and then we have this line which is x plus y equals to 6. Now we can find equation of pair of lines joining point of intersection of this line with the circle. Now this can be done by making the curve homogeneous, and if we want to make this circle homogeneous, we have to change its constant part. We'll write this constant part as x plus y by 6 square. If we want to solve it, we'll get equation of pair of lines as xy equals to 0, which are basically x-axis and y-axis, and the angle between them is pi by 2. Now in this question, we are given a triangle ABC in which CD is the median and BE is the altitude, and it is given that CD is equal to BE. What is the value of angle ACD? Now we need to find angle ACD, so we'll take this angle as theta, and we'll also take this angle A as alpha. So now we have theta and alpha, and suppose length of AB is 2x, and since CD is median, so this BD is x and AD is also x. Now in this triangle AEB, which is a right angle triangle, this is hypotenuse, angle is alpha, so AE is basically 2x cos alpha and BE is basically 2x sin alpha. So AE is 2x cos alpha and BE is 2x sin alpha, and we are given that BE is equal to CD. So therefore CD is also 2x sin alpha. Now in this triangle ADC, we have two sides and two angles, so we can use sine rule. So basically sine alpha upon CD, which is sine alpha upon 2x sin alpha, will be equal to sine theta upon AD, which is sine theta upon x. Now here x will cancel, sine alpha will also cancel. We'll get this sine theta as 1 by 2, which will give us theta as pi by 6, and that's your option D. Now this question number 10, we are given two circles whose equations are mod z equals 2 and mod z equals 3. So center z at origin, radius 2. So we'll draw the two circles. Let's say there are 2 points, z1 on first circle and z2 on second circle, and the angle between them is 60 degrees. Then the value of mod of z1 plus z2 upon z1 minus z2 is. Now for this z1, suppose modulus is 2 and argument is theta. So we can write this z1 as 2 e to the power iota theta. For z2, modulus is now 3 and its argument is theta plus 60. So we can write z2 as 3 e to the power iota theta plus pi by 3. Now we'll need to find the value of z1 plus z2 upon z1 minus z2. So we'll put the value of z1 and z2. Now what we'll also do is, we'll divide everything with e to the power iota theta. So it'll be 2 plus 3 e to the power iota pi by 3 and 2 minus 3 e to the power iota pi by 3. Now e to the power iota pi by 3 is cos pi by 3 plus iota sin pi by 3, which is 1 by 2 plus root 3 by 2 iota. So now it'll be this 2 plus 3 by 2 plus 3 root 3 by 2 iota, and then 2 minus 3 by 2 minus 3 root 3 by 2 iota. Now we simplify this, it'll be 7 plus 3 root 3 iota upon 1 minus 3 root 3 iota. Now we take their modulus. So mod of z1 upon z2 is mod of z1 upon mod of z2. So modulus of numerator will be 49 plus 27, and mod of denominator will be 1 plus 27, which is 76 by 28. And we can divide it with 4. That will be under root 19 by 7, and that's your option A. Now in question number 11, we are given 30 consecutive numbers starting from n plus 6, and it is asking for the maximum possible number of prime in this set. It is given that n is greater than or equal to 1. Now if we look at the sequence of prime, then starting from 2, 3, 5, we have written some numbers. Now if we look at first 30 numbers, in the first 30 numbers, number of primes is 10. But this is a special case because it is the only case where we have a number in which there is no other number between them. And what we also know is any prime number which is not 2 or 3, it is either of the form 6n minus 1 or 6n plus 1. So within a set of 30 consecutive numbers, so it can have maximum 5 numbers of the form 6n minus 1 and maximum 5 numbers of the form 6n plus 1. So maximum number of primes in any case or in a set of any 30 numbers can be 10, which is true for first 30 numbers. But thereafter, we can never have a situation where two consecutive numbers are prime, because one of them will be even and the other one will be odd. So it is not possible to have n equals 10 for any other set. So thus, the maximum number of prime in any such set will be only 8, and that's your option B. Any other questions? There are 40 distinct balls which are to be placed in 4 distinct boxes, such that each box has 10 balls, and out of these 40 balls, 10 are defective, and these 10 balls are to be distributed in the first 2 boxes. Now we need to find how many ways it can be done. Now let us say we have 4 boxes, namely 1, 2, 3 and 4. Now the defective balls, they can only go to box 1 and 2. So all the defective balls, they are already here. Now for 1 and 2 we need 10 more balls. So now we are left with 30 balls which are to be distributed in 10 and 20. 10 for this group and 20 for the group containing 3 and 4. So first we have to distribute these 30 balls in 2 parts. Now it can be done in factorial 30 divided by factorial 10 factorial 20 ways. So now we have 20 balls here and 20 balls here. Now these 20 balls are to be distributed in the 2 boxes. So you have to distribute them in a set of 10 and 10. Now it can be done in factorial 20 upon factorial 10, and we have not divided it by factorial 2 because these 2 boxes, they are distinct. In the same way, for the boxes 3 and 4, again we can distribute these 20 balls in 10 and 10 as factorial 20 divided by factorial 10, and if you want to simplify it, it will come as factorial 30 into factorial 20 upon factorial 10 to the power 5, and that's your option B. Now the question is, we need to find number of elements in this set when x lies between 0 and 2. Mod of x minus x to the power 5 equals x to the power 5 minus x to the power 6. Now we know that when x lies between 0 and 1, then as the power increases, number decreases. So basically x minus x to the power 5 will be positive and x to the power 5 minus x to the power 6 will be positive. So both these expressions, they'll have same sign which is positive. But when x lies between 1 and 2, as the power increases, the value increases. So in this case, x minus x to the power 5 will be less than 0 and x to the power 5 minus x to the power 6 will also be less than or equal to 0. So in that case, it will be both negative. Now either they are both positive or they are both negative. So in both the cases, the sign is going to cancel. So simply we can write this as x minus x to the power 5 equals x to the power 5 minus x to the power 6, which is x to the power 6 minus 2 x to the power 5 plus x equals 0. Now here we can take x common. So one of the root will be x equals 0. Now we need to check if there are other roots possible. So now what we are left with is this equation x to the power 5 minus 2x to the power 4 plus 1 equals to 0, and let this be equal to fx. Now if we find f dash x, it will be 5x to the power 4 minus 8x cube. We can take x cube out. So the critical points here are 0 and 8 by 5. So if we plot it on number line, rightmost will be plus. So plus minus plus. So at 0 there will be a maxima, and at 8 by 5 it will be a minima. Now we will find the value at 0. Now at 0, value of fx will be simply 1. We will find the value at 2. At 2, this is 2 to the power 5 minus 2 to the power 5 plus 1. So at 2 also this value is 1. And in this, we can also find the value of f1, because just by inspection we know f1 is 0. So it'll have a maxima at 1, it'll have a minima at 8 by 3, and then at x equal to 2, it'll attain the value 1, and at 1 it is 0. So now it'll come down at 8 by 3, it'll achieve its minimum, and then it'll go up. So this equation will have two real roots between 0 and 2. So one of the root is 1 and the other root is alpha. So there are three roots of this equation, 0, 1 and alpha, where this alpha, it lies between 8 by 3 and 2. So number of roots of this equation will be simply 3, and that's your option B. Now the question is, in a room with n people, each pair shakes hands between themselves with the probability 2 by n square and independently of other pair. If Pn is the probability that total number of handshakes is at most 1, then this limit n tends to infinite, Pn is equal to what? Now, number of people in the room is n. So the total number of possible handshakes will be nc2, which is n minus 1 by 2, and let us say this is capital N. Now the probability of handshake happening between the two people, it is given by 2 by n square. So probability of success is 2 by n square. So probability of handshake not happening or probability of failure will be 1 minus 1 upon 2n square. Now it is asking for this probability Pn, which is probability of having at most one handshake. So we need to find probability of x less than equal to 1, which is equal to probability of x equal to 0 plus probability of x equal to 1. Probability of x equal to 0 will be nc0 q to the power n. So here will be capital N, and nc1 q to the power capital N minus 1 p to the power 1. Now this is limit n tends to infinite. Now q is 1 minus 2 upon n square. So it will be 1 minus 2 upon n square minus n by 2, and plus capital nc1 is n, which is n square minus n by 2, and then into q to the power n minus 1. So it will be 1 minus 2 upon n square minus n minus 2 upon 2 into p, which is 2 upon n square. Now I'll actually solve this limit part. Now this is limit n tends to infinite 1 minus 2 upon n square to the power n square minus n by 2, and plus this limit n tends to infinite. Now we'll take these two together. So there will be n square minus n upon 2, and is multiplied with 2 upon n square, and then we have 1 minus 2 upon n square minus n minus 2 upon 2. Now this is 1 to the power infinite form. This also is 1 to the power infinite form. So here we are going to use two concepts in limits, and the concepts are, if we have this limit x tends to a fx to the power gx, and it is of the form 1 to the power infinite, we can write this as e to the power this limit x tends to a fx minus 1 into gx. Now since it is of the form 1 to the power infinite, we can write this as e to the power this limit n tends to infinite, and will be fx minus 1, which is 2 upon n square, and then will be n square minus n by 2 plus this limit n tends to infinite. Now here 2 will cancel, it will be n square minus n upon n square, and we can write this as e to the power this limit n tends to infinite. Now this is fx minus 1, so it will be 2 upon n square, and this is n square minus n minus 2 upon 2. Now the second concept in limits that we are going to use is, if we have an infinite limit and if we arrange these polynomial in decreasing power of x, this limit will have a non-zero finite answer if and only if the highest power of x in the numerator and denominator it is same. Then in that case, answer to this limit will be coefficients of higher power. So there will be a naught upon b naught. So here if you want to look at, this is e. Now here highest power is n square. Here also highest power is n square. Coefficient is minus 1. So this is e to the power minus 1 plus. Now here highest power is n square. Highest power is n square. Coefficient is 1. So it will be this 1 into, and here again this is n square. This is n square. We have this minus sign. So it will be minus 1. So answer to this limit will be 2 e to the power minus 1, and that's your option D. Now we have an interesting question in question number 15, and it says number of positive solution to this equation e to the power x sin x, and this is log x plus e to the power under root x plus 2. Now, if we look at these two functions separately, then first function is suppose fx, which is e to the power sine x, and second function is suppose gx, which is log x e to the power root x plus 2. Now, we know that e to the power sine x will oscillate within the bounds of e to the power x. So, it will be this graph. And if we look at g dash x, it will be 1 upon x plus e to the power root x upon 2 root x. And since domain is x is greater than 0, we are looking at number of positive solutions. So this function will be an increasing function. So we know graph of fx, we also know graph of gx, but the problem here is we can have so many possibilities. We can draw this graph like this, we can draw it like this, we can draw it at some point, it may like be above the graph of e to the power x. So this problem is not that simple. So the first part of this problem will be to define the relation between e to the power x and this other function log x plus e to the power under root x plus 2. So what we'll do is first we'll find number of solutions of this equation. E to the power x equals log x plus e to the power root x plus 2 or e to the power x minus e to the power root x, and that will be equal to log x plus 2. Now here too what we'll do is we'll consider them as two functions. Suppose this first function is f1x and this second function is f2x. Now this f1x is e to the power x minus e to the power root x. Now we know that when x lies between 0 and 1, e to the power x will be less than or equal to e to the power root x, or e to the power x minus e to the power root x will be less than or equal to 0. And when x is greater than 1, then in that case e to the power x will be greater than e to the power root x, or e to the power x minus e to the power root x will be greater than 0. So, and what we also know is f1 0 is 0 and f1 1 is also 0. So if we look at graph of this function fx or f1x, it will be drawn something like this. So this is 0, this is 1, and that's the graph of f1x, and that is e to the power x minus e to the power root x. Now this f2x function, it is simply log x plus 2, and basically this is y minus 2 equals log x. So basically we have to take the graph of log x and then we have to shift it 2 units upward. So this graph will be drawn like this. So it will intersect at 2 points. So this is the graph of f2x, which is log x plus 2, and it will have 2 roots, say alpha and beta. So we have 2 roots, alpha and beta, where alpha is less than 1 and beta is greater than 1. So this equation will have 2 real roots. Now, how is this information going to help us? Now, what we'll do is we'll restrict our analysis when x is greater than or equal to beta. Now, when x is greater than or equal to beta, in that case, graph of f1x will always be above the graph of f2x. So when x is greater than or equal to beta, there f1x will always be greater than or equal to f2x, or we can write e to the power x minus e to the power root x will be greater than or equal to log x plus 2, or e to the power x will be greater than or equal to e to the power root x plus log x plus 2. So from here what we can do is, if this is beta, then after beta, graph of e to the power x will always lie, or will always be above the graph of e to the power root x plus log x plus 2. Now after establishing this fact, now we can come to our original function, which is fx, and it was e to the power x sin x. Now for e to the power x sin x, the bounds are e to the power x and e to the power minus x. So we draw e to the power x and e to the power minus x. Now at beta, we are not sure about the phase of sin x. I'll take any random phase and then we'll draw the graph of sin x. So every time when this graph is going up and coming down, it is going to intersect this other line, which always is going to lie below the graph of e to the power x. So that means this equation fx equals gx is going to have infinite roots. So basically, the number of positive solution to this equation is infinite, and that's your option D. Now in question number 16, it says the smallest composite number that is coprime to factorial 10,000 upon factorial 9,900 is. Now if we look at this factorial 10,000 upon 9,900, then it will be the product of 100 consecutive numbers starting from 9,901 to 10,000, and these are 100 numbers, and we know that product of n consecutive numbers is always divisible by factorial n. So product of these 100 numbers will always be divisible by factorial 100. So any number between 1 and 100 is always going to divide this product. Now we need to find a smallest number which is composite, and suppose that number is of the form p and q, where p and q, they do not divide this product. Now we know that every number from 1 to 100 is going to divide them. So this p, it has to be greater than 100, and this q, it should be greater than 100. That means this n, it should be greater than 10,000, and that's your option D. And question number 17, we are given a region and all the points in the region are given by this set. Then we need to find the minimum value of x plus y. Basically, it's an optimization problem. Now we can define the region. Now the first line is y equals x plus 1. Now if we put origin here, we'll get 1 greater than or equal to 0. That means it satisfies the inequality. So the region will lie towards the origin. So it will be this side of this first line. Now if we look at the second line, it is x is greater than or equal to minus 1. So this is x equals minus 1. So x is greater than or equal to minus 1. It's going to be this region. And then we have this third region or third line, which is y is greater than or equal to 2x. So this is y is equal to 2x line. Now since the origin already lies in this, we'll take some other point. Let the point be 0, 1. So if we put x is 0 and y is 1, it will be 1 greater than or equal to 0. That means it is going to lie on this side of this line. So the region bounded by these three lines will be this region. Now we need to find minimum value of x plus y. We'll get minimum value of x plus y when x is minimum and y is minimum, which is intersection of these two lines, and this point is minus 1, minus 2. So x is minus 1, y is minus 2. So minimum value of x plus y will be minus 3, and that's your option B. Now in question number 18, we are given two sets A and B. A has 5 elements and B has 10 elements. Now it says we need to find number of ordered pairs of the functions f and g such that g of fx is x. So that means after this composition, 1 should be mapped to 1, 2 should be mapped to 2, so on and so forth. Now since this g, it is a function, so there must be at least 5 elements in g that must have images as 1, 2, 3, 4 and 5. Let us suppose those 5 elements are x1, x2, x3, x4 and x5. So the first step is, out of these 10 elements in B, we have to choose 5 elements which are going to be mapped with A. So number of ways in which we can choose these 5 elements is 10C5. So now we have 5 elements in A and 5 elements in B. Now these 5 elements, they can be mapped to these 5 elements in factorial 5 ways. So total number of functions f will be given by 10C5 into factorial 5. Now coming to this set B, this set B has 10 elements. Now for these 5 elements, we already know their images, right? If x1 is mapped to 1, then x1 must be mapped to 1 for this g of fa to be A. So image of these 5 elements, they are already defined. So number of ways of choosing image for these 5 elements will be simply 1. What we are now left with is 5 remaining elements in B, and for these 5 remaining elements, we need to find an image in this set A. Now for each element, we have 5 choices. For the first element, we have 5 choices. For the second one, we have 5 choices. So it will be 5 into 5 into 5, 5 times. So then it will be 5 to the power 5. So the total number of ways of doing it is 10C5 factorial 5 into 5 to the power 5. And if you want to solve it, it will be factorial 10 upon factorial 5, 5 to the power 5. And that's your option A. Now the question is, we are given this set S, which is 1 upon 10,000, 1 upon 10,001, up to 1 upon 160,000. We need to find largest positive integer not exceeding S. Now, basically it's a very standard question and it's a method of difference, and we have solved this question previously too. So in such questions, what we do is, we take root 2n and we know that it will be less than under root n plus under root n plus 1 and will be greater than under root n plus under root n minus 1. And if we take the reciprocal, sign will reverse. So we can write this as 1 upon 2 root n will be greater than or equal to 1 upon root n plus 1 plus root n and will be less than 1 upon root n plus under root n minus 1. Now we can rationalize it. If we rationalize it, we can get this as root n plus 1 minus root n will be less than 1 upon 2 root n and will be less than root n minus 1. Now we'll take this summation from 10,000 to 160,000 for all the 3 expressions, and we have taken this 2 both sides. So we have this 2 and then its last term will be under root of 160001 minus under root of 10,000, which is 100, will be less than S, and S will be less than 2 into under root of 160,000, which is 400, minus under root of 9999. Now this value is 600.003 and this value is 600.01. So basically the largest positive integer less than S is going to be 600, and that's your option C. Now question number 20, it's a simple question. We need to solve this inequality in mod of x. Now if we look at the denominator, this is mod x square plus 2x plus 2, which is mod of x minus 1 whole square plus 1. That means it is always positive. Its sign does not change. And when the sign does not change, we can simply cross multiply it. If we cross multiply it, we'll get this quadratic equation 3 mod x square minus 5 mod x plus 2 less than 0. We can factorize this as 3 mod x minus 2 mod x minus 1. Roots are 2 by 3 and 1 plus minus plus. We need less than 0. So it will be this less than 0. So answer to this question will be 2 by 3 is less than mod x is less than 1. So if x is positive, this 2 by 3 is less than x less than 1. And if x is negative, then it will be 2 by 3 is less than minus x is less than 1. Now the sign will change. So it will be this minus 1 x and minus 2 by 3. So answer to this question is this option C. Now the question is, consider the point of the form n comma n to the power k, where n is greater than or equal to 0 and k is greater than or equal to 1 inside the circle which is x square plus y square equals 100. So if the point lies inside this circle, then x square plus y square should be less than 100, and x is n and y is n to the power k. So basically n square plus n to the power k should be less than 100, or n to the power 2k should be less than 100 minus n square. Now n, it starts from 0. So if we take n as 0, we get only 1 point, 0 comma 0. If we take n as 1, again we'll have 1 point, 1 comma 1. Now for n equals 2, it'll be 2 to the power 2k should be less than 96, or 4 to the power k should be less than 96. Now we know that 4 cube is 64. So value of k should be less than 3. So here we have 3 points, 2 comma 2, 2 comma 4 and 2 comma 8. Now for n equals 3, the condition will be 9 to the power k should be less than 91. Now we know that 9 square is 81. So we'll have 2 points. Value of k can be 1 and 2. So the points will be 3 comma 3 and 3 comma 9. Now for n equals 4, we'll have 4 to the power 2k, that is 16 to the power k less than 86. Now 16 square is 256. So only one value is possible. So there will be 4 comma 4. In the same way, it will be 5 comma 5, 6 comma 6. And for n equals 7, we'll have 7 square 49. It should be less than 51. So there will be 7 comma 7. And hereafter, 8 to the power k will be less than 100 minus 64. There will be 36. Now this is not possible. So these are the only points possible. Now this is 1, 2, 5, 7 and for 11. So there will be 11 such points inside this circle, and that's your option A. Now here the question is, we are given a binomial expansion and it says we have to arrange them in the decreasing power of x, and suppose that the first three coefficients are in AP, then we need to find number of terms where x appears with an integer power. Now if we look at this binomial expansion, we can write its general term as NCR e to the power n minus r into b to the power r, and if we simplify it, we can get NCR 1 by 2 to the power r into x to the power 2n minus 3r by 4. Now basically it's a decreasing AP, so already the powers are in descending order. So the first three coefficients will be NC0 1 by 2 to the power 0, NC1 1 by 2 to the power 1 and NC2 1 by 2 square. Now they are in AP, so 2b equals a plus c, and if we want to solve it, we'll get value of n as 8. And when we have n as 8, if we put n as 8 here, this general term will be 8cr x to the power 4 minus 3r by 4, and this is 1 by 2 to the power r, where r varies from 0 to 8. Now power of x should be integer. It will be integer when the 3r by 4, it is an integer. That means this r, it can be either 0 or 4 or 8. So there are three possible values of r. So number of terms where x will appear with integer power will be 3, and that's your option A. Now the question is, we need to solve this limit, which is limit n tends to infinite 2 log 2, 3 log 3 plus n log n upon n square log n, which we can write this limit n tends to infinite summation r varies from 2 to n r log r upon n square log n. Now had it been log r by n, this problem would have been reduced to integral form, but in this case we have log r upon log n and not log r by n, so we cannot change it here. Now we have this summation r varies from 2 to n r log r, and what we'll try to do is we'll try and change it in integration of x log x. So here the function which is comparable to r log r is x log x, and if we look at this function y equals x log x, when x is greater than 1, its derivative will be 1 plus log x and it will be greater than 0, and second derivative will be 1 by x, which also is greater than 0. So it is an increasing function and it will be concave up. So let this be the graph of y equals x log x. Now basically 2 log 2, 3 log 3, 4 log 4, there will be nothing but there will be a snapshot of this continuous function at integral points. So if we take these integral points from 1 to n, and if we take their snapshots, so at 1 this value is 0, at 2 it is 2 log 2, at 3 this is 3 log 3, at r this is r log r, At n minus 1, it'll be n minus 1 log n minus 1, and at n, it'll be n log n. Now we'll come back to our series, which is this summation r varies from 2 to n r log r, and we'll take this is r log r into 1. So what we are doing is we are going to multiply r log r with 1, and 1 is basically width of this interval. So we are talking about area of rectangles. Now this is n log n. Now n log n will be this rectangle, n minus 1 log n minus 1 will be this rectangle, and 2 log 2 will be this rectangle. So basically this summation or this sum will have an area which is greater than area of this function from 1 to n. So this s will be greater than this integral from 1 to n x log x dx. Now there is another way to draw these rectangles. Now what we'll do is we'll draw them from starting of the point. So now this is 0. Now this rectangle from 2 to 3, its height is 2 log 2. Then here it will be 3 log 3. Then this is r log r, and this is n minus 1 log n minus 1. So this sum, it can be expressed as this summation r to n minus 1 r log r, and it will be less than this integral. Now it will be less than area of this curve. So it will be less than this integral from 1 to n x log x dx. Now what's missing in this is this last term n log n. So what we'll do is we'll add n log n both sides. So now from here we can write this sum, that is summation r varies from 2 to n r log r, will be greater than this integral from 1 to n x log x, and it will be less than this integral from 1 to n x log x plus n log n. Now what we'll do is we'll first solve this integral x log x dx from 1 to n. Now this is simple, which can be done with by parts. So if we take this integral x log x from 1 to n, this is log x as it is, x is x square by 2 minus x by 2 integral x square by 4 from 1 to n. So if we put the upper limit and lower limit, we'll get this integral as n square log n minus n square by 4 plus 1 by 4. So now we can write r log r, this summation will be greater than n square log n by 2 minus n square by 4 plus 1 by 4, and it will be less than n square log n by 2 minus n square by 4 plus 1 by 4 and plus n log n. Now we need to find this limit n tends to infinite summation r log r upon n square log n. So what we'll do is we'll divide everything with n square log n. So we have divided everything with n square log n. Now here n square log n will cancel. So it will be 1 by 2 minus 1 by 4 log n plus 1 by 4 n square log n. This is summation r log r upon n square log n, and this is 1 by 2 minus 1 by 4 log n plus 1 by 4 n square log n plus 1 by n, and then we'll take this limit n tends to infinite. So we'll take this limit n tends to infinite. Now this is 1 by 2. Now as n tends to infinite, log n tends to infinite, so it will be 0. N square log n will be 0. So this limit of the left hand function is 1 by 2. And the same way, this is 1 by 2. 1 upon log n is 0. 1 upon n square log n is 0, and 1 upon n is 0. So this also is 1 by 2. Then using sandwich theorem or squeeze play theorem, we can say that limit of this given function will be 1 by 2. And that's your option C. Now this is a number theory problem. It says let p less than q be prime numbers such that p square plus q square plus 7pq is a perfect square, then the largest possible value of q is. Now what we'll do is we'll let p square plus q square plus 7pq as sum n square. Now we can make it a perfect square. So it will be this plus 2pq minus 2pq. So there will be p plus q whole square plus 5pq. It will be equal to n square. Now we'll take it on the right hand side. So it will be this 5pq n square minus p plus q whole square. Now this is a plus b into a minus b. So this is n plus p plus q and n minus p plus q, and it will be equal to 5pq. So basically, the product of two factors on left hand side should be equal to 5pq. So what we'll do is, we'll take n plus p plus q as 5 to the power a, p to the power b, q to the power c, and n minus p plus q as 5 to the power 1 minus a, p to the power 1 minus b, and q to the power 1 minus c, where a, b and c, they can take the value 0 and 1. So basically we have to distribute 5pq in two expressions. Now what we'll do is, we'll subtract the second from first, then we can write 2 times p plus q, and it'll be 5 to the power a, p to the power p, q to the power c, minus 5 to the power 1 minus a, p to the power 1 minus b, q to the power 1 minus c. And since we have two choices each for a, b and c, so there'll be total 8 possibilities. Now we are going to write all the 8 possibilities. So it can be p minus 5q, q minus 5p, 5p minus q, 5q minus p, pq minus 5, 5 minus pq, 5pq minus 1, and 1 minus 5pq. Now some of the possibilities we can outrightly reject. LHS is positive. Now q is greater than p, so p minus 5q will be negative. 5 minus pq also will be negative, and 1 minus 5pq also will be negative. And if we look at this one, q minus 5p, so we can write 2p plus 2q, and this is q minus 5p. So from here we can write 7p plus q equals 0. Now since p and q are positive, this also is not possible. 5q minus p, so 2p plus 2q, and this is 5q minus p. Now this is 3p equals 3q. Now p is not equal to q. This also is not possible. Then we left with pq minus 5 and 5pq minus 1. Now we look at this case, when 2p plus q is p into q minus 5, we can write this as 2p plus 2q equals pq minus 5. We'll take this pq on the left hand side, and then we'll subtract 4 because we need q minus 2 common. So if we want to factorize this, we can write this as p minus 2 into q minus 2. It is equal to 9. Now we need p and q to be primes, and value of q should be highest. So basically this p minus 2, it is 1, and q minus 2 is 9. So p is 3 and q is 11. So the highest possible value of q is 11, and that's your option B. And then you can take up this case 5pq minus 1, but it leads to nowhere. So this case is also discarded. So answer to this question is 11. Now the question is, set of all real numbers x for which 3 to the power 2 to the power 1 minus x square, it is an integer, where x is a real number. So basically we are looking at all the integer values of this function when x lies between minus infinite and plus infinite. Now we have to construct this function. We know that x square lies between 0 and infinite, minus x square will lie between minus infinite and 0, 1 minus x square will lie between minus infinite and 1, 2 to the power 1 minus x square will lie between 0 and 2, and 3 to the power 2 to the power 1 minus x square will lie between 1 and 9. So range of this function is from 1 to 9. So this y, it belongs to not included 1 to included 9. Now what are the integral values possible? Integral values possible are 2, 3, 4, 5, 6, 7, 8 and 9. Now we know that if we put x equals to 0, we'll get this as 3 square, which is 9. So 9 is possible when the value of x is 0. Now for any other value, say 3 to the power 2, 1 minus x square is k, then we can write 1 minus x square as log 2 log 3 k, or basically this x will be plus minus under root of 1 minus log base 2 log base 3 k. So for every value of y, we are going to end up with two values of x. So each of these numbers 2, 3, 4, 5, 6, 7 and 8, they'll have two possible values of x. So the total number of ways will be, so this is 7 into 2, 14, and plus 1, 15. So set of all real numbers where this value is an integer will be 15, and that's your option B. Now question number 26 is a straightforward question. It says if A, B, C are three complex numbers, then this equation AZ plus BZ bar plus C equals to 0 represent a straight line on the complex plane if and only if. Now we know that equation of a straight line in complex plane is given by a z bar plus a bar z plus b equals to 0, where a is complex and b is real. So this b, it should be real. First we have to make this part real. So what we'll do is we'll divide everything with c. Now this is a z bar plus a bar z. So they are conjugate of each other. So we can write a upon z equals b bar upon c, or a bar upon c equals b upon c. Now from here we can write a upon c equals b bar upon c bar, or ac bar equals cb bar. From here we can write a bar upon c bar equals b upon c, or a bar c equals b c bar. And from here also, if we take its conjugate again, we'll get a bar c equals c bar b, and that's your option B. Now in this question we are given a circle in which there is this quadrant ACE, and in which we have drawn a rectangle. Now in the question it says DE is to AB is 2. So this ratio DE is to AB is 2. That means if this length AB is x, then this length DE, it is 2x. Now let the radius of the circle be r. Then this length will be r. This length is also r. And this length is also r. So basically this length from C to D will be r minus 2x. And this length will be simply r minus x. Now since it is a rectangle, this is r minus x, this is r minus x, and this is r minus 2x. Now in this right angle triangle, if we use Pythagoras, then we can write r minus x square plus r minus 2x square will be equal to r square. So this is our first equation. Now we need to find the ratio of FE upon FA. Now FE is this length. Now FE is basically r minus x square plus 2x square. So FE is r minus x square plus 2x square. Now we can replace r minus x from this. It will be r square minus r minus 2x whole square. If you want to simplify it, r square will cancel, 2x square will cancel. It will be simply 4xr, or 2 under root xr. And in the same way, we have to find AF, which is this. Now this again is a right angle triangle. So AF square is under root of x square plus r minus 2x square. Now here we have to change r minus 2x square with r square minus r minus x whole square. Here also x square r square will cancel. So it will be root 2 rx. Now we take their ratio, it will be simply root 2, and that's your option B. Now in this question we are given an increasing function which is defined on 1 to infinite, and it says this integral from 1 to infinite 1 upon bx dx, it converges, that is it is less than infinite, then which of the following must be true? Now it says it must be true. Now in this integral, if we let x as e to the power t, then this dx will be e to the power dt. So we can write this integral from e to the power t dt upon b e to the power t, and we need to change the limits also. So when x is 1, t is 0, and when x is infinite, t is infinite. So it will be this integral from 0 to infinite, e to the power t upon b e to the power t will also converge. Now if this integral converges, then this integral from 1 to infinite, e to the power t dt upon b e to the power t is also going to converge. And if this integral converges, then the series, which is basically snapshot of this function at integer points, and if we connect these integer points, it will be this rectangle. So this area is also going to converge. So this summation k varies from 1 to infinite, e to the power k upon b e to the power k will converge. So the correct option is this option C. Now in question number 29, we are given two statements. There exists a differentiable function g such that g x cube plus x to the power 5 equals e to the power x minus 100. We need to check whether such a differentiable function can exist or not. Now if it is differentiable, we can write g dash x cube plus x to the power 5 into derivative of x cube plus x to the power 5. There will be 3x square plus 5x to the power 4 and will be equal to e to the power x. We can write g dash x cube plus x to the power 5 as e to the power x upon 3x square plus 5x to the power 4. Now in the denominator, we cannot put the value x equal to 0. That means g dash 0 is not defined. This function is not differentiable at x equal to 0. That means statement 1 is wrong. Now statement 2 is there exists a continuous function g from R to R such that g e to the power x equals x cube plus x to the power 5. Now if we take e to the power x as t, then x will be log t. We can write this function gt as log t cube plus log t to the power 5 when t is greater than 0. But if we take this limit t tends to 0 positive gt, now log 0 is minus infinite and minus infinite cube will be minus infinite. This value, it approaches minus infinite. That means this gx, it cannot be a continuous function. And the reason being, they have defined this gx from R to R. So there will be other part of the definition which is going to be applicable when x is less than or equal to 0. But since at 0, this function, it approaches minus infinite, can never be a continuous function. So the answer to this question is neither 1 is correct nor 2 is correct. Now the question is, we are given two functions psi and f, and we are given that this integral from minus 1 to 1 psi x dx, it is 1, and we need to find this limit epsilon tends to 0, 1 upon epsilon, this integral from 1 minus epsilon to 1 plus epsilon fy psi 1 minus y upon epsilon dy. Now we have epsilon here, we have epsilon in the limits. So what we'll do is, we'll do substitution and we let 1 minus y upon epsilon as t. Then we can write y as 1 minus epsilon t. dy upon epsilon will be minus dt. So we can replace 1 upon epsilon into dy with minus dt. So it'll be this minus dt, and then it'll be this fy, and this is psi t, and y is 1 minus epsilon. And we need to change the limits also. So when y is 1 minus epsilon, it'll be 1 minus epsilon upon epsilon. So it'll be this plus 1. And when it is 1 plus epsilon, it'll be minus 1. So what we'll do is we'll change the limits and we'll consume this minus sign. So it'll be this minus 1 to 1, and y is 1 minus epsilon t, f1 minus epsilon t psi t dt. Now what we'll do is we'll take this limit inside this integral. So it'll be this minus 1 to 1 limit epsilon tends to 0 f 1 minus epsilon t psi t dt. Now if we put this limit epsilon tends to 0 here, it'll be this f1. So it'll be this integral from minus 1 to 1 f1 psi t dt. We can take f1 out. So it'll be f1 and then this integral from minus 1 to 1 psi t dt, which is given, and its value is 1. So answer to this limit is f1. Now basically, you cannot take this limit inside every integral. There are some conditions which must be fulfilled, but in this case, we can take this limit inside this integral function. So answer to this question is f1, and that's your option A.